servo in underscore in dot HBA1C. So if row is equal to, sorry, you say greater than equal to 6, we change it in there. All right, created a new variable. Let us do the label encoder also for this. So we have label encoded the data also. So we will scale the data. Before scaling the data, let us do some hypothesis test. Test null, the average FBS of weight of underscore type, diabetes type, no association underscore type, and gender. Test null, no association, diabetes type, and C rural. T-test, ANOVA, and Cascade test. 3 categories are there. Okay, female is 0, male is 1. So from scipy dot stats underscore in, T-test underscore in, we have not split the data, is equal to diabetes underscore in, square bracket, diabetes underscore in, dot gender, double equals to 0.0. Male is equal to 1.0. Female dot FBS equal underscore var is equal to false. Failed to reject null, right? Greater than 0.05, failed to reject null. So FBS and gender failed to reject null. Diabetes underscore in dot FBS only, right? Diabetes underscore in dot mean. Alphabetical order, na? IJKL MNOP. 0 is never smoked. 0 is never smoked. 2 is quit smoking. What is the other third category? Never smoked is equal to diabetes underscore in, square bracket, diabetes underscore in, dot smoking, double equals to 0.0 is equal to diabetes 1.0. This is for the smoking. From scipy dot stats f underscore one way, f underscore one way, never smoke dot FBS dot FBS. Then weight and waist of diabetes equal. Okay, we have already done this. Okay, dangerous is 0, diabetic is 1, normal is 2. 0 is dangerous, 2 is normal. Danger is equal to square bracket, diabetic in, diabetic type, double equals to diabetic is equal to normal is equal to f underscore danger dot weight, normal dot weight. Yes, weight is related. Less than 0.05. So you know the null, right? No significant in average weight of different for smoking also. Average FBS of different in average FBS of the null and alternate hypothesis, null hypothesis, which we are rejecting. So waste is there, no? So diabetes underscore in dot waste dot group by underscore in dot diabetic type dot mean. So means are different. So f underscore one way danger dot waste comma normal dot waste. Again, waste is a impact variable. 0.05. We check. How will you get for 0.08? Data is already split now. You should not split the data again. Danger, diabetic, and normal. Chi-squares is between diabetic type and gender, diabetic type and rural, and diabetic type and from scipy dot stats chi2 contingency. Chi2 contingency PD dot crosstab in dot diabetic type comma diabetic dot gender, right? P value greater than 0.05 failed to no association. Next is C rural, right? P value is 0.08 greater than. Last one is what? Smoking, right? Okay, we got reject nulls. Check for multicollinearity. Multicollinearity. Because we have many numeric variables here, na? No multicollinearity. Hello, बोलो भाई. ऊपर आओ, third floor reception. Third floor reception में आना है. Third floor reception में आना है. Third floor reception. Basement से भी आ सकते हो, left से भी आ सकते हो. Yes, no multicollinearity, right? Using the heat map, we can easily find about 0.95. That if multicollinearity happens, first threshold is 0.95. After that also you still find multicollinearity, then we will drop 0.90 also. Okay, because some instances 0.90 multicollinearity also will affect. But my experience is 0.95 and above. From sklearn dot pre-processing import standard scalar. To reduce the size, we will use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have split the num calls. Reception में दे दीजिए. Reception में दे दीजिए. See, we have already have a data frame, na? I want to do it within the data frame, not the. Let's try that one. Okay. Diabetes square bracket in dot I location square bracket colon comma 0 colon. How many? 14. 14 means you have to give 15. 14. No.
13.
14th column also has to be selected. 14. Okay. Is equal to dot apply standard scalar fit underscore transform. We are getting errors today, so many errors. Expected 2D array got 1D array instead. Okay, we can give like this. Columns is equal to columns will get equal to pd dot data frame standard scalar dot fit underscore transform underscore aim comma columns is equal to, we'll get the list of columns. Okay, got error. Using ILOC we got it. Okay, 21 and 15 mismatch. Okay, mismatch of 21 and 15. Okay, so where did you give ILOC? Here you gave, or here you gave? Oh, you got it, right? Why didn't I get it? Okay, you have defined a scalar. Scalar is equal to standard scalar. Diabetes underscore aim dot I location square bracket colon comma 0 colon is equal to scalar dot fit underscore transform. Fit underscore transform. Hey, LDL is not done here. See, 15. We have 15 here to give. Let's diabetes in, where is it? Or we will do it separately. Only one column, na? We missed. Scalar dot fit underscore transform diabetes in dot expected 2D array got 1D array dot LDL dot fit underscore transform. On one place we are getting stuck. 14 column. Okay, no problem. We will run all. Apart from imputation, where we have done the imputation, why it is not working one column standard scalar single column? Oh, we have to give only one column, na? So we can use the top one only. Diabetes underscore n dot I location column comma 15, no 14, right? 14 scalar dot fit underscore transform. We got stuck. If we run imputator, it will take time. It is already scaled. Except LDL, everything is scaled. Only one column we have to scale. But that will be double scaling, na? Scaling on scaling. It is scale on scale. It's wrong. Okay, we will use square brackets. Square bracket single quote LDL is equal to scalar dot fit underscore transform. What the hell is happening there? Dot apply dot fit underscore transform. Yeah, that will take time, na? 1 second before we implement. Let us check if the data is earlier data is also same. Minus 1.5. Age 1.52638. Yes. Yeah. So this is the right one. See, wasted 15-20 minutes unnecessarily. So now we have our data fully cleaned, pre-processed. Everything is done. Hey, where is diabetes type? Oh, here we have HbA1c, right? So we have to drop HbA1c. The column itself is gone. This is what happens if you don't rename the columns properly. We completely lost it, right? We don't have any option but to run all. Y is equal to from a scalar dot linear underscore model. Only diagonal values are correct. Rest of all are wrong predictions. No requirement. तो आपने वो गैस भर दिया क्या अभी? नहीं, आपका दूसरा बंदा भी आया था ना? ठीक है, नो प्रॉब्लम. मैं बिल अभी व्हाट्सएप कर दूंगा. लेकिन प्रॉब्लम क्या है? फिर से लीक हो रहा है क्या? वो पहले लीक हो. HbA1c డ్రాప్ చేయలేదు మీరు, అందుకని ఓవర్ ఫిట్టింగ్ అవుతుంది. HbA1c డ్రాప్ చేయలేదు కదా? So here you have to drop HbA1c, otherwise it will be over. So rest of all models are multinomial models. Decision tree, random forest, all those things are multinomial models. You can directly build them. All of you got the output, right? confusion matrix as well as classification report. Slight imbalance is there because one category is very less, no? Diabetic. So you can try balancing and then do it. So categorical features we have to give. So we have to define it separately. SMOT is equal to SMOT NC. Categorical features is equal to square bracket hypertension, smoking, gender, and diabetes type, right? X underscore SMOT, comma Y underscore SMOT is equal to SMOT dot with underscore resample X comma Y 0 to 18. Column names it is not taking, huh? You have to create a list, huh? Cat underscore calls is equal to. I have given like that only, na? 14 or 15? 14, na? Square bracket 14, 17, 18, right? Oh, it worked. 3492, 3492, 3492. So this is the process of dealing with imbalance. Index numbers we have to give. No, you can't do. ROC is a binary. ROC curve is for only binary, for not for multi-class. Cross-val score and classification report. Accuracy, classification report, and cross-val score. Because ROC curve is a binary curve. So rest of the models, decision tree, random forest, gradient boosting, neural networks, naive Bayes. Naive Bayes you will use multinomial NB. Naive Bayes you have to use multinomial NB because this is support vector classifier, then KNN, all these things can be run. Run all those things and we will see which is the best fit model. We do it on the SMOT data only, that would be better. Only for logistic regression you have to give multi-class is equal to multinomial. Other algorithms will automatically detect. And naive Bayes, it has to be multinomial NB, right? We have categorical NB, Bernoulli NB and all. It has to be multinomial NB, naive Bayes. That is the only thing. Build up models over the weekend and we'll see next class what